last thing we talked about last time I saw you was credit cards, how credit card billing works. So my billing cycle, this is a made-up example, by the way, but Caitlin's credit card billing cycle runs from the 19th of each month to the 18th of the next month, which means that some days it's 30 days, some months it's 30 days, some months it's 31 days. And my interest rate is 17.5%. And I went on a fabulous vacation in May, racked up a lot of charges on my credit card. When it came time to pay my June credit card bill, I left a balance of $1,140 on the card. I couldn't pay everything off, so this balance is going to get carried forward to my June bill. So I start my June 19th to July 18th billing cycle with a previous balance of $1,140. In addition, I made 3 purchases. Dates and amounts are shown in this little table here. And then I also made a payment on July 15th of $550. All right, so I want to find my average daily balance on my credit card. So I just moved this over here so I would have a little more room. So let's see, I'm going to put dates, number of days, and balance. Okay, so my billing cycle starts on the 19th of every month. So I'm going to have June 19th until June 20th. That's 2 days, right? What was the balance on my card for those 2 days? $1,140. Good. That's just the carryover from the previous month. And then on the 21st, I made a new purchase. So 6/21 until 6/29, because on the 30th, I made another purchase. So until the 29th, I added $177.23 to my balance. So let's see, I need a calculator. So 1140 plus 177.23. 1317.23. All right, and how many days is that, the 21st to the 29th? 9 days. All right, and then on the 30th, I made another purchase, and my balance remained steady from that day until the 4th. Okay. And I need to add $40 to my previous balance. So my balance for that set of days is 1357.23. And how many days is that? 5. 30th, 1st, 2nd, 3rd, 4th, 5 days. And honestly, count on your fingers if you have to, because it can be confusing. Like, is that 9 days or 10 days or 11 days? So just count them if you have to. All right, and then starting on the 5th, and up until I made this payment, so until the 14th, I put another $90.67 on the card. And so that's $1447.90. And the 5th to the 14th, so we've got 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th. That's 10 days. And then on the 15th, I made a payment. And my billing cycle ends on the 18th. So the 15th to the 18th, that's 15, 16, 17, 18. That's 4 days. I now can take $550 off of that balance because I made this payment. Oops. And it's now $897.90. Okay, so now to calculate my average daily balance. When I say take an average, that means add it all up and divide by the number of things, right? So how many days are in this billing cycle total? 30 days. 2 plus 9 plus 5 plus 10 plus 4 is 30 days. Okay, so I want to take each day's balance, which I have 30 of. Each day there's a balance on my card, right? So I have 30 balances. Add them all up and divide by 30. But I don't have to actually write down 30 balances because many of my days have the same balance. So instead, average daily balance is going to be, well, I would do 1140 plus 1140, but writing 1140 plus 1140 is the same thing as 1140 times 2. Right? And then I would add 13, 17, 23 9 times, which is the same thing as doing 13, 17, 23 times 9. So I add 9 of those. And then I have 13, 57, 23 5 times, and 14, 47, 90 10 times, and then 8, 97, 90 4 times. And that's all divided by 30 days in the billing cycle. So we just type this all into a calculator. And I'm not going to bother because I have the answer right here. 1299.73. That is called my average daily balance. And it is used to calculate how much interest I'm going to be charged. My finance charge uses average daily balance. 1299.73. It's the only thing it's used for. It's just used to calculate how much interest the credit card company is going to charge me. So your interest charge or your finance charge, those are synonyms, is calculated by doing your periodic interest rate times average daily balance. Do you guys remember how to calculate the periodic interest rate? Close. Close. That would be your daily interest rate, but we're making, this is being done monthly. So you'd think it would just be the interest rate divided by 12, but it's not because different months have different numbers of days. So you take the number of days in your month, which is what? 30 in this case, divided by 365 times the interest rate as a decimal, which my case was 17.5%, so I used 0.175. And then you multiply that times your average daily balance, 1299.73. So now I need a calculator. So 30 over 365 times 0.175 times my average daily balance, 1299.73. So I get $18.69. That's called your finance charge or your interest charge. So to find the balance on the account at the end of the billing cycle, June 19th to July 18th, I have to take what my balance was when I started, right, 1140, add all your purchases, 177.23, 40, and 90.67. And I actually already know what that comes out to, right? Because I did it 1447.90. Oops. Right? And then subtract any payments you make, minus 550. And that's 897.90. And then add on your interest charge, which was 1869. And that comes out to $916.59. So the next bill you get on your credit card is going to say $916.59. All right, so in this section, we're going to explore something called annuities. And this is saving for the future, if you want to save for a car or a house or for retirement or any other reason you want to save. So suppose Jen is saving up for a car. So she's going to put aside $200 per month in an account that pays 6% annual interest compounded monthly. So here are two questions. One's easy and one's hard. How much money will she have invested in 3 years? How much total money will she have set aside? $7,200. $200 a month, right? Times how many months? 36, yeah, because there's 36 months in 3 years, right? So $200 a month for 36 months is $7,200. So that's the amount she will have set aside, right? But if she invests it as she saves it, instead of just putting it under her mattress, she puts it in an account that pays 6% interest. So she's actually going to have more than $7,200 when she's done. But we can't use the formula we learned about compound interest several classes ago because she's not putting all $7,200 in at once. She's putting in a little bit at a time. Okay, so how much money she will have in 3 years will be more than $7,200, but exactly how much more is a difficult question to answer until we learn about a fixed annuity. Okay? A fixed annuity is a sequence of equal payments made or received. So you can either be making, this is where we're making payments to ourselves, right? Making $200 payments to ourselves to save. So you may be making regular deposits to save for a car, a vacation, a wedding, or you may be making regular payments on a loan or a mortgage. You can also be at the receiving end of an annuity. You might get regular payments from an inheritance or from a lottery jackpot. So these are all examples of annuity. Equal payments made over regular intervals. So here's the formula for a fixed annuity. F stands for future value, and capital P stands for how much money per month, right? How much money per month. And little p is your periodic interest rate. In general, if you're going to make monthly payments, it's going to be your interest rate over 12, right? But if you're going to make, in more general sense, your periodic interest rate is your interest rate divided by how many payments per year. So most frequently, it's going to be R over 12. Sometimes it'll be R over something else. So this is my formula. Future value is equal to P, which is your monthly payment. And then little p represents your periodic interest rate, and capital T represents the number of payments. Okay? So it's not years, it's number of total payments. All right, so now we can tackle this question about Jen saving for her car. She's putting $200 per month in an account paying 6% annual interest compounded monthly. So you see that monthly, and then P is your periodic interest rate is going to be R over 12. So how much money will she have in 3 years? So they're asking about the future value. So I'm going to be figuring out what F is here. And I have to know all these other variables, capital P, little p, and capital T. Okay, so capital P is the monthly payment amount, which would be what? $200. Capital P is $200. Okay, little p is your periodic interest rate. Because we're doing this monthly, we take the interest rate that's 6%, 0.06, and we divide by 12. And I think that's 0.005. So little p is 0.005, and then I need capital T, which is the number of monthly payments. How many monthly payments is she going to make? 36. She's doing this for 3 years, monthly, 36 deposits of $200. All right, so now we have everything we need. We plug into this future value formula. $200 times, this will be 1 plus little p is 1.005 to the 36 minus 1 over 0.005. And then I'm going to suggest that you do all this in a calculator so you don't lose any decimal places. So I'm going to just type this in following the order of operations. So I'm going to do this exponent first. I'm working inside the parentheses because you always do in the parentheses first. Then I'm going to do the exponent, 1.005. Well, this calculator can't do exponents. 1.005 to the 36th power. Enter. Big long decimal. I don't want to write it down, so I'm just going to do the next step using this. The next thing I should do is subtract 1. Minus 1 equals. So I've saved all these decimal places. Then I have done all of the numerator. I'm going to divide by my 0.005. And then I should multiply that times 200. Okay, so I figured out everything in the parentheses, then multiply by the 200, and I get $7,867.22. Does that answer make sense given the amount that she has invested in here? She put in $7,200, and over 3 years, she made $600-something in interest. Seems like a reasonable answer. Does that make sense? Okay, but unfortunately, Jen has her heart set on a car that costs $10,000. So how much more would she need to invest? What should her capital P be? Instead of 200, what does that number need to be so that F, the future value, will be $10,000? So this time I'm going to make my F a 10,000, and the thing I don't know is P, the monthly payments. And this is all the same, 1.005 to the 36 minus 1 over 0.005. See if you can do the algebra here. Solve for P. Okay, so basically 10,000 is equal to P times something. And this something is just kind of a mess, right? I just have to calculate what that something is in my calculator. Just being careful to make sure I follow the order of operations. So let me pull up my calculator. So I'm going to do my 1.005 to the 36 minus 1 divided by 0.005, and it's 39.34 approximately. So I now have 10,000 equals 39.34 times P. Okay. So now I just have to divide both sides by that 39.34. And when you're writing numbers down to show me what you did for work, do whatever you want for rounding. But when I actually do the division, 10,000 divided by this number, I'm going to use the whole long decimal that was in my calculator. There's no reason to write it all out because your calculator can save that number. You're just showing me what you're doing for work. And we end up with P equals. All right, so I want to save this number because I need to do 10,000 divided by that. Every calculator has a way to store numbers. So many of them have the words STO with a little arrow, and you can store it as a letter, like store it as the letter A. So if you have a scientific calculator, like this one, when you have the number you want, right above on, there's a STO with an arrow. Press that button, and then a list of letters comes up, and you say, oh, okay, I'm going to store it as A. You just hit enter to choose A. Yeah. And then, if you want to pull A back up, its second store says RCL, that's for recall. If you want to pull that number back up, you recall it. So I would do 10,000 divided by, and then I hit recall, and I get my list of numbers again, and I would choose A. On this kind of calculator, a more simple one, these buttons at the top, M stuff, that all stands for memory. So I want to put this number in the memory of my calculator, so I add it to the memory by pressing M+. Now it's stored in my calculator. I can press clear, and I can do 10,000 divided by, and then I press MR for memory recall. And I get 254.22. Oops. So that makes sense. $200 would save her almost $8,000. She has to put in an extra $50 a month to get to her goal of $10,000. To do the recall? Let me see. Okay, so you stored it as A. So now it lives in your calculator as the number A. Hold on. All right, so moving on. Sandy won the lottery. She has two options for how she can receive her winnings. She could take one lump sum of $500,000 today, or she can get a check for $10,000 every 3 months for the next 20 years. Assuming Sandy could invest her money in an account that pays 5% annual interest compounded monthly, which should she choose? All right, so let's look at option 1. Lump sum, right? So it's going to be paying annual interest, and she's going to put a whole chunk of money in this account at once. So we talked about how to use annual, the compound interest formula several classes ago, and it looked like this. It was future value is present value times 1 plus r over n to the nt. Right. N is the number of times you compound per year. R is your interest rate. T is number of years. P is present value. F is future value. All right, so let's see. We're going to put $500,000 in this account. And it pays 5% interest, so I put a 0.05 in there. And N is a 1 in this case because I'm compounding annually, 1 time per year. And then I raise that to the 0.05 times, how many years is it going to be in there? Let's say 20 years, yeah. We'll compare how much she has in this account to how much she will have in the other option at the end of 20 years. All right, so 1.05 is what happens when I do the parentheses, right? 1 plus 0.05 over 1, that comes out to 1.05. I have to raise that to the 0.05 times 20. And then multiply that, oh, it's not 0.05, I'm sorry, I messed up. That's just to the 20th. Just to the 20th. 20 times 1, right? Because n is the number of times. Okay. Silly, silly. All right, 1.05 raised to the 20th. And then multiply that by 500,000. And after 20 years, we're going to have $1,326,648. And 85 cents. All right, not bad. Pretty decent. Let's see what kind of money she'll have if she takes option 2. Okay, so this is an annuity. We have a fixed payment. So I'm just going to write down the formula for the annuity. It was F equals P times 1 plus little p, capital T, and I can't remember, minus 1 over P. Minus 1 over little p. All right, so remember, F is future value, P is payment, right? The amount of each payment. Little p is the periodic interest rate. Capital T is the number of payments. All right, so what's capital P? What are my regular payment values? $10,000. Okay, so I have 10,000 for capital P. Okay, little p is your periodic interest rate, which is your yearly interest rate divided by how many times you get paid per year. How many payments are we getting per year here for this $10,000? 4. If you get one every 3 months, you're going to get 4 per year. So I have to calculate little p by taking my yearly interest rate, 0.05, and dividing by 4 equal payments per year. That's my periodic interest rate, 0.0125. And then I raise that to the capital T, which is the number of payments I'm going to get. How many $10,000 checks am I going to receive total? 80. Yep. 20 years, 4 a year. So I'm going to get 80 of those checks. And then I have minus 1 over 0.0125 for little p. So now I'm just going to have my calculator do all of this so that I don't have to write down any decimals here. So I have 1.025. That I'm working inside this parentheses first. The 1 plus the 0.0125 is 1.0125. Raise that to the 80th because exponents come next. Then I subtract the 1. Oh, thank you, thank you. 1.0125. Right, thank you. To the 80th minus 1, then divided by 0.0125. And then I multiply all of that times 10,000. And I get $1,361,187.95. So that's the future value of her money, assuming she takes every $10,000 check and invests it right away. And in option 1, she takes the whole $500,000 and invests it right away. Which option is better? Second option comes up with an additional $35,000 or so. Yep. So option 2 is the one we're going to choose. That make sense? Okay. So in this case here, I should just write little p, just so when you go back and read your notes, you'll know where that 0.0125 came from. It's the yearly interest rate divided by the number of times we get paid per year. All right, now it gets good. Ian and Caitlin decide to begin saving for their retirements. We love teaching at GCC, but we don't want to work here forever. So we're going to open a Roth IRA. We're each going to open a Roth IRA. It's a great investment vehicle if you haven't ever heard of it. It allows you to invest up to $5,000 per year. You put in the money after taxes was taken out from your paycheck. So after you get your net pay, you can put $5,000 away per year. And you do not have to pay taxes on the gains, right? So when you retire and you take that money out, you don't have to pay taxes on the money you made through this investment. So the downside, though, is that once you put your money into a Roth IRA, it's basically locked up until retirement age. If you want to use the money before that, you have to pay steep penalties. There are certain exceptions, like if you're going to buy your first house, I believe you're allowed to take some of that money. Yeah. Education and medical also, yes. There are certain exceptions. All right, so assume that your IRA earns 7% interest per year compounded annually. So Ian, on his 34th birthday, he's going to deposit $2,000 into this IRA. And on each of his 9 subsequent birthdays, he makes another $2,000 deposit. But then he stops investing into the account. So he's going to make a total of 10 $2,000 investments. And Caitlin's going to follow a similar investment plan, but I'm going to start saving at 22 instead of at 34. Okay, so on my 22nd birthday, I put in $1,000. I'm only 22. I don't make that much money. So I put $1,000 a year into this IRA. Like Ian, I'm going to make 10 equal annual deposits, $1,000 a year for 10 years. So Ian is investing double what I'm investing, but I'm starting 12 years earlier. We want to see how much money each of us will have when we retire on our 64th birthdays. All right, so this is a tough question. If we made investments all the way up until we retire, then we could just do an annuity, right? We could just use the annuity formula that we've been using all class. But we stop investing, and then we continue to let that money grow. So we have to answer this question in 2 steps. 1, figure out how much money we have after our last deposit. We'll use the annuity formula for that. And then 2, pretend that after we make that last deposit, we take all the money from that account and we invest it into a new account that will just grow until retirement age without us touching it. All right, so here's Ian's scenario again. 34th birthday, puts $2,000 in, and then 9 more deposits of $2,000, 7% per year annually. How much will Ian have after he makes his last deposit? So this part, we just use the same formula we've been using all class. Future value is your monthly, is your investment amount, the regular investment value, times 1 plus little p to the t minus 1 over little p. Okay, so how much is capital P? What are his regular deposits? $2,000. So I replace capital P with $2,000. Little p is my periodic interest rate, which would be what? It's 0.07. I'm doing this once a year, so you take my yearly interest rate, and I don't have to change it because I just do this once a year. So this is going to be 1 plus 0.07 to the capital T, which is the number of payments I'm going to make, which is 10, or Ian is going to make, right? Minus 1 over 0.07. All right, so let's see how much money he has when he turns 43, right? 10 after his 10 investments. So I'm going to work inside the parentheses first. So I add my 1 and my 0.07, and I get 1.07. Then I do the exponent raised to the 10th. Then I subtract 1. Divide by 0.07. And then I multiply by 2,000. All right, so after the 10 equal payments of $2,000, his investment, his IRA, is worth $27,632.89. So 10 $2,000 deposits is $20,000, right? So he put $20,000 in, and because this account is making interest, he ends up with 27,000 something. Make sense? All right, so at the end of his investments, he has it's worth $27,632.89. All right, now suppose that he opens a brand new account, and he's going to take this money and invest it. No more payments, it's just going to grow using compound interest. 7% compounded annually. So the formula for that is 1 plus R over N to the NT. So this is an account that just grows with no deposits or withdrawals. So my P for principal is my $27,632.89. Okay. 1 plus, my interest rate is 0.07. I'm compounding annually, so I just divide by 1. And then I raise that to the N times T. N is 1, and T is years. So how many years is this going to grow for? 20, I think. Yeah. So he started on his 34th birthday. So 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. So he's 43 when he makes the last deposit. And then we're going to go from 43 to 64. How many years is that? 21 years? 21 years. So he made the last deposit on his 43rd birthday, and he's going to take this, he's going to invest this money until his 64th birthday. That's 21 years. All right, so let's see how much money he's going to have. Sorry, what? Yeah. For 10 years. So on his 34th birthday, he makes a deposit. So 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. So it's his 43rd birthday that he makes the last deposit. And then from there until his 64th birthday, he's 21 years. All right, so I have 1.07, just doing what's in this parentheses first. Raise that to the 21 and multiply by my principal, $27,632.89. All right, so in this retirement account, when he retires, he will have access to $114,415.70. Okay. All from an initial investment of $20,000. Not bad. All right, let's see how much I will have. We're going to figure out how much Caitlin has at retirement now. Remember, I started my 22nd birthday, 10 equal amounts, just like Ian, of $1,000 though. And then I stop adding money to the account. I let it grow at 7% annual interest. Take a few minutes, see if we can figure out how much I will have when I retire.